Okay, let's get started. As I emailed you yesterday, I uploaded some notebooks. There's a link, and the examples I gave last time, I gave two versions. One is just the HTML version, which doesn't run. And the reason I did that is if you go there, the top part explains about, well, gives you links to the Apache Tori, which is a kernel for Jupyter Notebook, which allows you to run Spark in the Jupyter Notebook, right? And the documentation is pretty sparse. There's basically a quick start guide and an installation guide, and that's it. And once you've installed that, it's then possible to actually download the example and then run it, right? But until you actually install the Tori kernel, downloading the actual notebook won't do any good because you won't be able to run it. So, okay, any questions so far?
Do we need Apache Tori on top of Spark?
No, yes. Apache Tori is just a kernel for Jupyter Notebook, and it assumes that you have an installation of Spark on your machine. When you install Tori, it's that it wants to know where is your Spark installation, and you can tell it in two ways. One is when you actually install it, you say, and here is where my installation of Spark is, and that's what the instructions tell you to do. You can also have a environment variable called Spark Home set to where your installation is, and then it'll pick that up. Okay, any other questions? And then I want to start off looking at another example. Can everyone read this? Should I make it bigger? So last time I said that in Spark, there are transformations and there are actions, right? And the transformations are all done lazily. And so I wanted to look at that and show evidence that indeed is the case. And so what I first do is, if I want to deal with the DataFrames, I need a Spark session. And so I just create a Spark session. I create one function to write to a file, another one to read the file, and I create a third function which returns a Boolean to determine whether an integer is even, right? And then what I do is I'm doing SC, which stands for a Spark context, right? And the Spark context is used as the entry point again to create RDDs, right? So when I say range, I'm getting RDD back, right? And the arguments to the range are, let's see, the first one is the start of the range, end of the range, increment, and the second argument, the last argument, is the number of partitions I want on that RDD, right? So I want two partitions, which is all I can really handle because, well, I can handle more, but this machine only has 2 cores, so why do I want more partitions? And then what I do is I write to the file for one reason, make sure it exists, and put some text in it so I know to start. And then what I want to do is I create a filter, and filters are transformations, right? And then when I read the file again, and there has been no output to the file, right? No output to the file. Okay, then what I do is I call count, and count returns the result. It's an action, right? That triggers my transformation on the RDD, right? And then when I read the file, there's more output there, right? And notice that the output's not in order. Actually, it's two orders intertwined. There's the 5, then the 6, and the 7, the 8, increasing order. And then there's the 1, 2, 3, and 4, increasing order. Why? Because I have two partitions, right? They'll be done on separate threads, hopefully on two different cores, and so that those interactions are intertwined. So far, so good. What's that? The right? Right foo? Right foo is it's just a Scala function. It's not using Spark. No, right foo, transformations and actions refer to operations on RDDs and DataFrames. And so that's just a pure Scala function. Right? So I call count, that triggers that transformation, right? And I get output to the file. I call min, it's another action, and you see there's more output to the file. Why? Because that filter is called again, right? Because it's done lazily. It doesn't cache the result. It doesn't say, okay, I've computed it once, now I can save the result. It says, no. Every time you do an action on a RDD or a data frame, we recompute all those transformations that build up. Right? So that's one comment, right? Just reinforce the idea that, well, the transformations are done lazily. I only have one transformation here, but I could have done more, right? And then they all would have done each time I did an action. The second thing is demonstrating that, okay, indeed, we are not doing this in a single thread, right? If we did, then we should get those numbers in order, because when you have a range, the data frame, RDD has them in order. So we definitely have concurrent processing going on, right? Now the third thing you probably didn't notice is that if we go back up to my right foo, I'm actually I give it a string, and the second argument is a boolean whether I want to append or not. I then actually no, I do it in is even. I first write to the file, and then I print out the standard out, right? But you don't see this print line coming anywhere, right? So when I'm in the notebook, I'm saying, oh, is even print line not happening? Well, it is happening, but where is it is even being executed? Well, so where is the transformation being executed? Right? Is even is inside the filter, and the filter is a transformation. Where are transformations being executed? They're being executed on the worker nodes, right? Not on the main node. And so when I print a standard out on a worker node, where is standard out? I don't know, right? If we're on a cluster, standard out, I mean, it's being run on a different machine. And so you don't expect to see the output when you write the standard out, right? So far, so good? Okay, now let's try doing the same thing on a data frame. Now it's Spark range, right? And the Spark is a standard notation for a Spark session, right? And again, I'm getting a data frame back, and you can look at the values, right? They're in order. Right, and then what I do is I write the file again with the pen being false, so it's overriding everything. So now the file just contains start. I call my filter, but for a reason we'll get into in a little bit, I can't call is even there. So I'm passing in, right, an anonymous function that writes to a file but only writes one word, and then it prints the standard out. And then here's my actual filter at the end. And there are a number of weird things going on here. One is that the filter is actually a string, which should tell you that something weird is going on. And then this shouldn't be there. It's wrong key. So let's rerun everything. Just run all. Take a little bit. Right, so I run this. The first thing happens is the print line is working. And that tells us, oh, wait a minute. This is not happening on the worker nodes, right? It's happening on the master node, right? Otherwise, we wouldn't see it. And when we read the file, we're getting, it was written to. But it's only happening once, right? It's only happening once. Now, I call show on it, which is an action. I call count on it, which is an action. And I call take two, which is an action, right? Which means each one of those actions should trigger the transformation to be redone. So we don't see dog coming out, and when we look at the file again, it hasn't changed. And you go, wait a minute, I thought you said that, right, transformations are lazy, so how is it that we only get dog coming out up at once and the file doesn't get changed? Well, if we actually call explain on that data frame, it gives us a plan, right? And the plan is how we're going to evaluate that that data set with all transformations, right? And there are a number of different steps. The first one is the parse logical plan. That is, this parses what we're supposed to do without worrying about whether or not the columns we ask are there or not. And so you notice that, okay, the plan contains, the first thing is, it's a range, right? From 1 to 10, step 1, and then splits. How many splits? There's 2. Does anyone know what the sum means? No? 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 Does anyone know what an optional value is? You better know what an optional value is, yes. So this is an optional value, which means it may or not be set, right? Optionals are sort of a relatively new construct in languages to try and reduce the number of times you get exceptions. So there are times when you may have a value that's not been set yet. Rather than making it nil, they'll call it an optional. And when you deal with it, you have to unwrap the optional to get the value out. And so the splits may not, it's possible that that's not set. That's why it says sum. So that's the first step is to compute the range, and then we call a filter. And notice that the filter does not have the rights, right? It just has ID divided by 2 equals 0. Now, what's that saying? Well, when we create a data frame, each column needs a name, right? And if you don't give it a name when it's a range, you get the default name, which is ID. And that little tick mark says, oh, treat this as a column name. And so the filter, right, pick ID divided by 2 equals 0. What that says is, apply this operation to each row, right? And replace ID with the value of that column on that row. And then if that question is still true, then what we'll do is keep that row. Analyze logical plan. What that does is it starts to learn about type. Although type's correct, are the columns you say you want to access, do they actually exist, right? And so you see all of a sudden their ID is a big int, and they're worrying about type. To optimize logical plans, okay, now how can we do this most efficiently, right? Now that we know that what we're supposed to do, we know the types exist, we know they're all consistent, and we know the data you ask for does exist. How can we just be very efficient, right? The physical plan is how do we actually execute this thing on the machines we've got available, right? So what's going on here is several things. One is, right, RDDs are executed differently than DataFrames. RDDs will not have a plan. So if you ask for a plan, you won't get it. You also notice the filter on the RDD was a normal filter we're used to in Scala, where you just pass in a function, a Boolean function. We're not passing in a Boolean function, right, per se, on the filter on a data frame. Basically, what's happening is the data frames they built a little language that we can use inside the filter, and there are several different ways to represent that language, and one is basically a string. Any questions? In the takeaway, our message are transformations are all done lazily, right? And they're only executed when you perform an action. And if you call several actions on the same RDD or data frame, you're going to re-execute all those transformations. And once you've installed the Apache Torre plugin or kernel, you can download this notebook and run it and see it for yourself in action. Any questions? So let's, like I said, there's RDDs, DataFrames, datasets, they're immutable, and there's transformations and actions. And actually, when you go to the RDD class, they'll show you, here's the list. Here's transformations, and here's actions. Same thing with DataFrames and datasets. There it is. We talked about doing the shell. Some examples. Talked about using FDB, sample programs. Now, for me, it took me a while. You kept on reading, oh, there's RDDs and there's data sets and there's data frames. Like, what? What's the difference between this and that? So it's like, okay, what are they? What's the difference? When to use which one? And what language can use them, right? A data frame, right, is a table with rows and columns, like you're used to seeing, right? So here's an example of a data frame. It has two columns, right? And the columns have labels. And if you've done any work with SQL, it's like this is, right? You've seen this before, right? And if you're dealing with SQL, you never worry about how they store a row, right? They just store it somehow, you don't care. But when you make a query, you get a bunch of stuff back, right? But here, in the data frame, the rows are stored as a row object, right? And they have a, you can look it up. There's also a schema associated with the table, and that is the labels for each column and the data type each column represents, right? So at this point, right, a data frame looks, it's just an SQL table, right? It has, rows and columns, and we store rows somehow, and you've got a schema, and you even use the word schema in SQL, right? Also, the data frames are very common. If you work on Python, the pandas have a data frame, right? Julie has data frames. R has data frames. I'm pretty sure that MATLAB has data frames. And they're all basically the same thing, right? Same name, same thing. Spark as a partitioner. So each data frame has a partitioner to just tell how we're going to divide this thing up into across multiple machines. We don't need that in SQL because we assume it's all being run on one machine, right? And it also has a plan, right? When you perform a bunch of transformations on it, you build up this plan on a data frame. So basically, a data frame is just an SQL table that can be run on multiple machines, right? And we access through Spark. And you can basically Scala, Java, Python, or any JVM language can use a data frame, right? And they're also optimized. So Spark has what they call their Catalyst optimizer, which optimizes the performance. And that's what we saw in the plan, right? Where there was the parse plan, I forget the second one, then the optimized plan. And the optimized plan has gone through the Spark optimizer to optimize the performance. Okay, so far so good. So you can really think of the data frame as just like an SQL table that we can then use on Spark. And it can run on multiple machines. Okay? A data set. A data set is basically a data frame, but we don't use the row object to store a row, right? You define a row class. You know, and in Scala, you define a case class with a typo missing an E. And in Java, you'll define a Java bean, right? And what that means is then the Scala case class of the Java bean defines the data type of each column, right? And it also gives a name to the column, which means the compiler knows the data type for the column and the name of the column. It's known as compile time. When we have a data frame, the compiler does not know the data type or the name of the column. So the compiler cannot check, right? But if we have a data set, the things are known at compile time. So the compiler can do some more optimization, right? Basically, you have to use a JVM language to use a data set. It's not available from Python. It's not available from R. Why? Well, because you need, at compile time, the data types, right? And Python doesn't have type annotations. Neither does R. So there's no way to do it. So you don't get to use a data set. An RDD is a table of arbitrary data. So we don't have a schema associated with it. There's no schema, which means there's no labels for the columns. We don't know what the data types are going to be, right? So the compiler can't check our type, right? And the runtime can't check the type, right? It just assumes it's like Python. You just do it, right? And if you pass in the wrong type, well, too bad, you get a runtime error, right? Same thing here. All the basic operations are basically the same between data frames, data sets, and RDD, right? Map and filter, and pretty much the same. Since you don't have the data type, you can't do much optimization, right? So the Catalyst optimizer to optimize performance is not there. There's no space optimization. So in one example I came across, using using the same data set, right? Loaded into RDR, took 33.3 megabytes. Loaded the DataFrame, it took 7.3 megabytes. Why? Well, because there's a schema associated with it, and the optimizer at runtime can optimize, right, the layout of the data, right? And what Scala does, what Spark does, right, the native Java data types are too inefficient. They don't use them, right? So when you have int or float or string, all those data types come from Java or Scala. Spark does not use, because the memory layout is not appropriate for big data. All right, so it rolls their own data type. It basically does its own memory management to avoid all the garbage collection occurs in Java. Now the problem we have, you can indeed use RDDs from Python and R, but I came across one member and said, you don't want to do it. Why? Well, because there's no type information here, and there's no type information here, right? And like I said, the Spark types the Java types are not space efficient, right? So the string ABCD, it takes up 48 bytes. Why? Well, because there's all this overhead, right, of objects. And that's just too much, right? When you're dealing with large data sets, you don't want to take up all that space on object overhead. Another problem we have with Java types is there's too many pointers.
What?
Well, first of all, Scala does use types, right? It is a type check language. It's just it has type inference, so you don't have to type in the types, right? And so Scala is probably even more tightly typed than Java. And so what's happening here is Spark says the types that we have in Java, the JVM, are for general use, right? They're appropriate they're usable everywhere, but not optimized for any particular operation, right? Well, so first of all, what's one of the problems with objects, right? One problem with objects is there's in Java, there's overhead. For each object, you have basically 40 bytes of overhead. And that's a lot of overhead when you're dealing with large data sets, right? The second problem is, if I have an array of objects, right, what do I have? The array can be a block in contiguous memory, but the actual information is located, scattered all over the place, right? And the problem with that is then when you want to then access that data in that array, you can cause a lot of paging to go on, right? And so no. If you want high performance, you don't want objects, right? Because they're all pointer based and you cannot get locality of data. And locality of data is really, very important, because as soon as you start paging, you're basically really slowing the machine down a lot, right? Right. When they introduced their own types, it was for a project called Tungsten, and Tungsten sped up Spark by a factor of 17. And the main thing they did was introduce their own types to worry about space usage and make sure that you got locality of data so you weren't missing all the cache hits. Right? Now, it does mean that what they're doing is allocating their own block of memory, and they have to deal with that, right? And that's something you'll typically want to do by your right? Now, so Spark has its own types, and then each language, right, there's a mapping between the language type and the Spark type. Well, in Scala, it's pretty direct. I mean, I didn't do all the types, but there's, right, the byte in Scala goes to byte type in Spark. And Python, this is fun because an intro long can map to a byte type, and then the same integer. And now you got this problem is you got this number thing in Python, and you're gonna send it over to Spark. And which data type is it appropriate? Should it be a byte, a short, or a long, or right, an integer? And reference, like I said, like the problem becomes unstable because you start, if you might then send it to the wrong type, and later it causes a problem because you might say, oh, you can send to a short, but then as it gets bigger and bigger, it no longer fits in a short. So they said it's not recommended to use Python or R with RDD. So basically, if you're using Spark, any non-JVM language is second class, right? They want support to other languages, Python and R, because they're so popular among data scientists. But you're a second-class citizen. You will not be as performant as you will be if you're using Java or Scala, right? And since computer science students in general, not analysts, right? They don't do numerical analysis, right? Your advantage over a statistician is you can write performant code. That's why I chose Scala instead of Python for the course. Some more terminology: structured versus unstructured. In the Spark world, structured means data sets and data frames. Why? Because there's a schema there that tells you what the columns are, the data type and names, right? Unstructured means already ours because you don't have that schema. This one's a bit more confusing. Type versus untyped. By type, you mean data set. Why is it type? Because the compiler knows the type of the columns and the name of the columns, right? DataFrames, the typing is there, but it's runtime information, not compile time information, right? So people call it untyped, even though the type is there and the optimizer can do it, but it doesn't at runtime, not at compile time. Okay? So this terminology, there's a lot of terminology. These are common words. So let's look at some more examples. And so I stole some examples and data from a book that's supposed to come out next month. It's not the definite guide, it's Spark: definite guide. The Riley website claims it will come out next month. It's in a pre-release, the third version of the pre-release now. So there's flight data in JSON format, and it's basically JSON, so it's origin country, Romania, destination country, United States, and then account presumably how many flights are passed by that criteria, right? So in claiming there are 15 flights in 2015. I assume it's not 15 separate flights, it's 15 different scheduled flights, right? They may occur frequently, I mean, once a day or once a month or whenever, but right, it's a long list, right? And so we'll use this data as an example for examples coming up. How to read JSON data? Well, it's just, there's a file name, a the location, and then Spark read JSON in the file name, and it reads it. And since I'm using Spark, again, the convention is that Spark represents a Spark session, and when Spark sessions generate data frames and data sets, right? And you see the return value it's a data frame. And it's smart enough to take the key values, right, in the JSON format to make that the name of the column. And yeah, I take a couple of them and you get an array of Spark rows, right? So each row is represented by a Spark object. And there it is, the first two, United States, Romania, 15, right? United States with ratio 1.
Yeah. So
I don't know I haven't tried that out yet, so I don't know the answer. But you have to keep in mind what we're doing is we're creating a data frame, and a data frame is an SQL-like table, right? And it's got columns and rows. And so if you start doing complicated with JSON, how are you going to map that onto a single table? Right, yeah. So my guess is you don't want to do complicated things in JSON, but something we need to try. And again, the whole thing is everything is lazy until you call an action, right? So the file is not read until you say take two. And we call take two, the file is read, right? And then we can take it. There is this function called explain, and that gives you the plan, right? Shows you what's going on. If you just say explain, it gives you the physical plan, just the physical plan. If it's explain with true in it, you get all 4 plans. Here I'm calling sort on it, right? And sort to the transformation. We're going to create another data set, right? And so it returns it says it's a data set. And notice what we give, right? The argument of sort. It's a string, right? So we're dealing with data sets and data frames, right? We then are generating this little language. So it's going to take that string and assume it's a name of a column. And then it's going to sort the data in that, in this case, data frame based on that column. And when we look at the plan again, we start getting, we have to read the file, and then we have to sort it, right? And until we actually do an action on it, we're not going to read the file, we're not going to sort it. And again, we'll talk about this more later, but since we're sorting it and we have the data separated in multiple machines or multiple partitions, to sort it, we're going to have to pass data back and forth, right? So the sort will trigger what they call a shuffle, right? Because if I want, in this case, I'm sorting by number, so they have to figure out, okay, what's the smallest number, what's the largest number, and then figure out a dividing point and say, okay, all the ones on machine B that are low numbers have to go to machine A, and all the numbers, all the elements, the rows that have a larger number have to go to machine from A to B. And now when you take two, the whole thing gets triggered, and now we start getting it's sorted, right? So it's sort of a cheap way. I mean, it's a simple way to sort data that's spread across multiple machines. Questions? No. Right. Again, we have this, right? We build up these transformations, and they're not done until we do an action. It also allows it, if we need to, if there's some problem, right, a node goes down, right, we still have that plan around so we can then recompute its part. Again, we read it. It's a data frame has schema, and we can ask for it, right? So here it is, the schema, and it says, oh, look, there's a field called destination country name, and it's a type string type, and the third argument is whether it's nullable or not. There's a fourth argument, which is optional, which is metadata about the field. Right, and so there's four elements to a struct field, and right, since we were dealing with JSON, I could figure it out. Why? Because the titles came from the keys, and JSON does have types. I mean, there's numbers and strings, right? So I know what's the number of string. What about, what if we're dealing with a CVS file, right? You basically have columns, but there's no data information. It's all strings, and there may or may not be headers. And how do we know that the first row is supposed to be a header for the columns, right? So in this case, we can do things like, okay, what we're going to do is we're going to get a reader and then say, well, look, yes, there's a header on this file. We'll treat that as the name of the column. And then first schema, and then what's going to do is we're trying to figure it out, and it's going to look at not the first column because they know it's the first row, but the first row is just the header. Look at the second one and say, well, I can't convert Andy to a number, so it's not a number, so I'm going to treat it as a string. I can't convert 30 to a number, so I'll treat that as a number. And it's not a float, right? There's no period, no decimal point in it, so it infers that. Okay? And so then, that's the table we get. And that's, then we can, if you want to see the data frame, we can do show on it, ask for the schema. We can print the schema, and so it gives us a little more readable format for it. So we can read JSON, we can infer what's going on, we can read comma-separated files. With comma-separated files, we have a bunch of options we can tell it about. So here it's just a redoing the example as a program as opposed to something in the Spark shell or on a Jupyter notebook. And so I'm creating the Spark context, configuration file session, reading the file, blah, blah. But there's one thing I want to point out here, and it's something you have to get used to. You have to keep it, you really have to keep track of this. There is a stop. When you run Spark, the default option is to keep the machine, is for Spark master to keep a lock on all the worker machines until you tell it to stop. Right? Which means that your Spark JVM is still running on the worker threads, even though a worker machine, if you haven't, until you call stop. So if you forget to call stop, you're still controlling the worker machines. And if you're on a system like AWS, you might be also being charged money, right? So when you're dealing in your own machine, or you're dealing with, right, you don't care about stopping, but this is something that bothers me at times. In Scala, you don't have to do types, right? And you're like, what is that? What can I do with reader? I don't know, right? Because I don't know what reader is. Then if you know, once you know what data type is, you know what you can look for. And then it turns out that, of course, you want to do this, either you have to specify the full name or you have to import it. So there's a language we can run on DataFrames. There's a select, so we can select various columns. So I give it select and give it a column name. Right? And there's my data file. But there's shortcuts we can do. We can then specify it as a column, right? Make it more explicit. I want the column with this label. And if you like abbreviations, you can, the same class that gets a column. Yeah. And then I can say instead of COL, parentheses name, I can do column. We can now do operations on columns, right? So I can say, oh, let's do a select. I want both the name and the age, but I want to add one to the age. And what I get is another data frame, and the name of the column one is age, name, the other is age plus 1. Of course, the syntax is a little awkward, and so there's some shortcuts we can use. if we're using Scala, not Java, not R, not Python. I can put the dollar sign in front of the string, and it tells it's a column. One subtle point is that when I did a select with only one column name, I could do it as a single string. If I left the dollar sign off here, you'd get a compile error. So I can do this in Scala or Java. And Scala, I can do a shortcut with a dollar sign. I can also do a single tick. It's supposed to be a single tick, not a quote mark. That quote there is I'm not sure why editors are so insistent upon converting single tick marks into single quote marks. So there's some shortcuts we can do in Scala. Here doing some filters on a data frame, right? On the first three lines are all equivalent. Dollar sign age says, oh, I want to filter, right? The rows or the column age is greater than 21, or I can do column, right? Or I can say column age dot gf. I also could have done the tick mark age greater than 21. So again, you see where the arguments to filter are not functions, or this little language. Group by, okay, group by age. It's going to group by and count the number of elements in each group. Now, this starting to sound familiar. Anywhere else you've seen these operations before? Okay. The SQL, right? There's select and group by. There's a reason it's called Spark SQL. Well, yes. We can save our data frames. Eventually you do this transformation to do something. Okay, I want the answer out. You can write a data frame. It's right, and then the format you want, and then what name do you want to put it under? Now, when I do this, right, you get a directory, and the directory will contain multiple files. The first one is either success or failure, and the 0 byte file that tells you whether things were repeated or not. The next one is going to be part 00 and part 01. Why? Because what happens when you write this and you've got multiple machines, right? And they all have their own partial copy of that data frame, right? You'll then get when you go to ELF, you'll get each machine will write its own version, each part of the data frame in a separate file. You don't want to use the standard Java or Scala right into a file when you got a data frame, because you have to remember you're on multiple machines, right? And then, since we got this little language that's sort of mimicking SQL, it turns out that you can just use SQL. That's it. And what you do is you create a temporary view, again, which is from SQL, right? Creating a view. And so you create a view and give it a name, and then you can run your standard SQL statements on that table. It's not a very interesting SQL statement, but it's an SQL statement.
All the different ways to do it.
Well, so yeah, the question is, I can either do straight SQL, or I can do all these selects and group by, right? And the question is there a preferred way? We can ask that in two different aspects that I know of. One is one faster than the other, right? Am I losing something by doing the SQL way or doing it directly? And the answer is no. Their catalyst optimizer is going to optimize them both the same ways and produce the same resulting code. So there's no performance reason why to select one or the other. Then it becomes basically a preference. Which do you prefer? If you're an SQL expert, you're going to lean towards just doing everything SQL, right? Because that you know. The one thing I don't like about these little languages you put in strings is that there's basically only runtime error checking, right? So if you do a typo in your string, you find out when you run it. So the other way we can break it down into smaller pieces in each function, it's a little bit better, but the arguments are still strings. And sometimes you can get away with doing these crazy things with column names and greater than. So there's a little more checking, but not much. Okay, any other questions? Yeah, so the question is, why ever use RDD, right? Because the space requirements are much larger and it's much slower, right? When you read the Spark documentation, from the Spark site, they basically say, yeah, you should be migrating to DataFrames and datasets. The newer books come out saying, yeah, that the datasets and DataFrames are, right, the preferred way of doing things now. Yeah, they started with RDDs, right, and DataFrames and datasets came later. Although, one last thing with RDDs is you get to use it. You're just coding, right? You're not having to struggle with the little language you build inside of. For example, I started a class with, right? On the RDDs, I could call a function in my filter, right? You can't do that with a data frame. Why? Because the data frame argument expects this little language, right? And Scala functions are not part of that language. Yeah, tonight when you go home, look at that example with that's part of the class with. It's online. You can download and look at it, and you'll see that okay, I did things differently with RDDs. My filter, I just passed in an is even function that I created. Whereas with the DataFrames, I didn't do that. I gave it a anonymous function where I inlined everything. I did that because I had to. When you put the function there, it says, I'm sorry, I mean, it's the wrong type. This also mimics a current trend. When big data first became a thing, there was movement away from SQL to NoSQL databases. But then people sort of soured on that because it turns out that SQL has all these nice built-in things like you need reports and you get that out and do it in a uniform way. Whereas each NoSQL database, you have to write yourself, and then each one is different, right? That's a lot more work. And so people are now migrating back out of NoSQL to SQL. And so RDRs is like RDDs is sort of the standard programmer's way of doing things. And now with Spark SQL, they're migrating to basically treating it as a big SQL engine. Any other questions? Yeah, again, one warning. The show, what does show do? It prints things out. Where does the output go? It's great when you're learning and debugging, right? But in a cluster, it's not going to do any good. And let's see. Another method that's useful is collect, which is just bring the result back. It's an action. And when I do this, right, I'm now bringing that data frame back to the master, and now I can start accessing it. And it collects it now as a data frame, but it's an array of rows, right? And so now I can deal with it as pure data in a Scala language on a single machine. Any questions? Well, I do have more slides, but I didn't post them. So we'll end here. You should be reading online documentation Spark and start reading the Spark book, trying to make sense of all this stuff and how to do filters and maps and collects and group by. And particularly, you might want to focus on how do you compute an average value, a column that might focus your attention. Yeah, and the thing to be careful about the assignment, you already can compute the mean in Scala, but when you do it, it's done on a single machine, right? And there's no way to spread across multiple machines, right? So now we want to do it in Spark in a way in which when we do it on RDD or a data frame, it'll be automatically parallelized for us, right? And so the way you did it on assignment 2 won't work. Okay?